Use the definition to find the derivative of f of x equals sine 2x, then evaluate f prime of pi over 6. The first thing I'm going to do is write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. The next thing I'm going to do is formulate f of x plus h. That means to take f of x, sine of 2x, and replace every x with an x plus h in parentheses. Sine of 2 times the quantity of x plus h. Then we're going to subtract from that f of x, which is just the sine of 2x, and all of that is divided by h. The next thing I'm going to do is distribute the 2 into the first sine function. So we will have the sine of 2x plus 2h, and then minus the sine of 2x all over h. We have the 0 over 0 indeterminate form, and we have this resulting because of trig functions in the numerator and a power function in the denominator. So we're going to make use of the identity involving trig and power. But before we can do that, we need to use the sum identity for sine. That's going to be our next step. So f prime of x will equal the limit as h goes to 0 of the sine of 2x plus 2h becomes the sine of 2x, the cosine of 2h, plus the sine of 2h and the cosine of 2x. And then we have the minus sine 2x, and all of this is divided by h. What we're going to do now is group together like trig functions for the variable x. And so we have limit as h goes to 0 of sine of 2x, cosine of 2h, and minus sine of 2x. We had two terms that had sine of 2x in them. Group those together over the denominator of h. And then we have one term with cosine of 2x. That'll be the sine of 2h and the cosine of 2x. And all of that is over h. So we have limit as h goes to 0. I'm going to factor a sine of 2x from the first fraction, giving us cosine of 2h minus 1. All of this is over h. This has a 0 over 0 indeterminate form because of the cosine of 2h minus 1 in the numerator as h goes to 0. That's a trig combination. I'm going to need to multiply it by the trig conjugate, which will be cosine of 2h plus 1. And we're going to put it over itself, a form of 1, so that when we multiply it, we don't change the value, just the look. The second fraction is also 0 over 0 because we have a sine of 2h over an h. I'm going to isolate the sine of 2h. I need to put it over a 2h to phase match it, and then I'll put a 2h in the numerator of the other fraction to compensate for it. Our next step is to FOIL out those trig conjugates. That will give us cosine squared of 2h plus cosine of 2h minus cosine of 2h, and then minus 1. And then we will multiply the denominators, but we don't want to distribute. We'll keep it factored. The second fraction, we have h's that can cancel, so I'm going to cancel those out, giving us 2 cosine 2x. And then we have the sine of 2h over 2h, which is perfectly phase match, and we'll have a limit of 1. Now for the first fraction, the outside and inside terms will cancel after the trig conjugate FOIL. I'm going to write the identity. Cosine squared of 2h plus sine squared of 2h equals to 1. I can subtract the 1 to the left side, so cosine squared of 2h minus 1, and that will equal the negative of sine squared of 2h on the right side. And that's what I can replace that with in our first fraction. So we have limit is h goes to 0 of what will be sine of 2x times negative sine squared of 2h all over h cosine of 2h plus 1 plus 2 cosine 2x sine of 2h divided by 2h in parentheses. So my first fraction now also has sine of 2h's that need to be isolated. I have a negative in the numerator multiplying, so that negative will just be in the front. I'm going to have a sine of 2x. I'm going to have an h, a cosine of 2h, and a plus 1. And I'm going to isolate the sine of 2h. It's squared, so it's quantity squared is how I'm going to write it here. And now I need to phase match that one by putting a 2h in the denominator. Now that's a 2h quantity squared, which is 4h squared, so I'm going to compensate by putting a 4h squared in the numerator of the other fraction, so those would cancel back out and go back to the original. But the reason we did that is that sine of 2h over 2h as h goes to 0 will limit to a 1. And I have plus 2 cosine of 2x times the sine of 2h over 2h. As h goes to 0, the sine of 2h over 2h, those are going to become a 1. Now from this first fraction, I can cancel one of the h's out. Each of these will become a 1, so I can put a 1 in them. And all remaining h's, I can now put a 0 in their place. So I have a negative sine of 2x times 4 times 0 over the cosine of 2 times 0, and then plus 1, and then plus the 2 cosine of 2x. Now in the numerator, I have negative sine of 2x times 0. In the denominator, I have cosine of 0 plus 1. And then all of this is plus 2 cosine of 2x. In the numerator, 0 times sine of 2x is 0. In the denominator, cosine of 0 is a 1 plus a 1 is a 2. 0 over any non-zero number is equal to 0, plus 2 cosine of 2x will give us 2 cosine of 2x. And there's the derivative of sine of 2x. The other thing we need to do is evaluate this at pi over 6. We want f prime of pi over 6. F prime of pi over 6 will then be 2 cosine of 2 times pi over 6. We can reduce the 2 pi over 6 by a 2, and that will give us a pi over 3. We evaluate the cosine of pi over 3, which is a 1 over 2. Multiplying these, we get 2 over 2, which can reduce by 2, and we get a 1.